Hey guys, today's question is sum of prefix scores of strings. In this question, we are given with an array of strings and we have to determine the score of prefix for every array. The score is determined as the number of string words I such that the word is a prefix of word I. Let's understand it by example. So the words array is given as ABC, AB, BC and B. There are 4 strings and the score of every string is 5, 4, 3, 2, 1 correspondingly. So as we can see for ABC, if we take this ABC, this A is a prefix of this element also and the second element also. So we add up the score by 2. Now the second prefix is AB and we can see AB here and here also. There are 2 prefixes AB. So the score is 4 now, and finally ABC is also a prefix of ABC. So the score is 5. Now for this AB, you can see this A, the first prefix, is also here. So the score is 1 plus 1 equals to 2. Now after this AB is here and here also. It is also a prefix here. So the score is 4 and so on. So we have to find the score for every prefix of a given string. Now we can do this question by a similar approach that we used yesterday, but not using the set. We will use an ordered map, but I have tried that approach gives the time TLE. Okay, I don't know why, as the constraints are same as 10 to the power 6, but that approach gives TLE. Maybe I'm missing something, but we can do this also by using try data structure, and we could also have done the yesterday's problem by try data structure. So let's use the try data structure, and we know for try data structure we have to create a structure and we have to make 2 functions get and insert, and we will simply insert all the values in the answer array by using the get function for every string. So what we can do is we will simply first declare the structure, and we don't need to add any character in structure because we just need to check the score. So we will use an integer variable, let's say of any name, let's say count. So if we will declare integer count equals to 0 for every structure, and we will increment counter whenever we reach that state in inserting the strings. Okay, so another thing that what we will do for inserting, for simply try data structure, we will first create a head node, okay, the root node. After that, as we found A, we will make a children A in the first index. So first declare the structure to understand it. What will be the structure of our node? Let's name it as try node, and we don't need to add any character in this structure, only the array of the children's. I assume you have done it before, the try data structure. 26, try node as structure 26, and let's take count as 0 for everyone. Initially all these values will be null. Okay, so what we can do in this main function, first we will create a head node. Okay, so try node extract node equals to try node. Okay, this is the head node. Let's take a pointer as head node. Let's take it as root equals to node. So we declared our head node. Now after this, let's take a vector to return in the end. Let's name it as answer. Now we will call 2 functions. We will run 2 loops. First for loop for inserting these strings in the try data structure, and we will also increment the value of counter at every stage because we have to return the sum of the prefixes. And after that, we will again run a loop to get these indexes value and add them up to return in our answer. Okay, so first run a loop for inserting. So for int I equals to 0, I less than words dot size, plus plus. Now we'll make a, let's say, insert function, and we'll pass root and the current word. Okay, so words of I. After this, we also have to run a loop for getting the values and inserting in the vector. So we will use, wait a second, so it's get here, and we have to push this value in the vector. So write it here only, answer dot push back this value. Okay, and after the whole execution, we will return answer. Now let's create these two functions. First, the insert function. So won't return any value, so this is the void type function. Void insert. We are taking two arguments, try node. Let's name it as pointer, the root that is passed, and the next value is string. Also, let's create the get function, which will be int type, and also both things are passed. So try node as pointer and a string s. Okay. Now this insert function, what we can do, we will simply run a loop, and we will update our values like see. While coding, I will explain that. So for int I equals to 0, I'm just traversing the string. So s dot size I plus plus. Now there are two cases that the current string is present or not. For example, when we are iterating over this string, none of them is present. So all the values of the children of the root is null. So if this is null, what we have to do is we have to create this node and update the counter as count plus plus for that. But let's say we traverse whole of this string, and now the function is passed for the second string. Function is run for the second string. So we can see that a is already present. So we'll just simply go to that a and increment the counter again, because we found that twice. Okay. So there are two cases, if the value is present or not. So if the value is present, then the PTR of children of the current index will be present. And how will we determine index? By simply subtracting the sky value. So a will be subtracted by a will give 0, and also given that all the letters are in lowercase only. Okay, so that's why we created only 26 size array. So a minus a is 0 and b minus a is 1, and so on. So we will simply go to the index s of I minus a. This will give the index for this array. And now if this value is not null, that means we can go to the next pointer and update the value. Okay, so Peter will be just updated like this. Just copy this and update PTR equals to PTR of children as of I minus a. Okay. Now after this, as I told, we have to update counter at every point, because we found that string, found that prefix again. So PTR count equals to PTR count plus plus PTR count plus 1. Now in the else case, if we don't found that string, then I said that we have to create the string. So first create the node. If we don't found that node, then we have to create that node. So node equals to new try node. Okay. Now we will connect this node to the parent. So the parent is currently PTR. So PTR, the index will be again same as we calculated for this one, s of I minus a. And now mark it as node to connect these two parents and children. After that, we will go to that children and update the value, same as we done before. So let's just simply copy this, or you can also write PTR equals to node. Okay, that is also fine. In this line, you can write PTR equals to node. That is same as it. So beta equals to beta SF5 and SA, and we will update the counter. Now we complete the insert function. Let's just complete the get function and run this code. So for the get function, as we have to return the counter, so let's take the CNT as we take count as 0. So let's take another variable CNT, and after the execution we will simply return this counter. Okay. And we use the integer function. Okay. Now we will run a loop and check and update our assembly, and we will simply update our CNT counter by incrementing it by the current value which is stored in the count. Okay. So just simply write that. A second. Run a loop in the string. So for int I equals to 0, I less than s dot size I plus plus. Now ptr will go to the next value, which is the current element children. So ptr equals to ptr, again the same thing, determine the index by s of I minus a. Okay. Now we will just simply increment the CNT by the current count present at that character. Now this looks fine. So let's run this. Okay, forward to add this semicolon after structure. Let's run again. A second. Okay, let's submit. So code is accepted. Thank you for watching.